Okay, so a number of people struggled with this question, and specifically, I suppose, part B here, but I'm going to go through the full question from start to finish. So it says the diagram shows a solid cylinder of diameter 30 and height 50 centimetres. A cone of the same diameter and of height 45 centimetres is cut from inside the cylinder. So I'm going to zoom in here, and I'm going to mark in that this is from here to here, because that's the height of the cone is 45 centimetres. Okay, so the first thing it says, find the volume of the cylinder in terms of pi. So that means pi is going to be in my answer. Volume of a cylinder is pi r squared h. So that is going to be, in terms of pi, means I leave pi in my answer. R squared, the radius of this cylinder is going to be 15. So 15 squared, and height is 50. Which I am getting here to be 11,250 pi. So that's the answer to part 1. The next one then says in part A, part 2, it says find the volume of the cone. So volume of a cone, you have specific formula, and that is 1/3 pi r squared h. So when it comes to the cone here, it's going to be, and I'm going to rewrite it as 1 multiplied by pi multiplied by r squared, which is going to be 15 squared, multiplied by h, which is 45, all over 3. And then I'm going to use my calculator then to kind of make that a little bit easier. So that is going to give me 225 multiplied by 45, which is going to give me 10,125 pi, all divided by 3. And if I divide that by 3, I should get the volume of the cone is equal to 3,375 pi. Okay, so the third part of that question then says, what fraction of the cylinder remains after the cone is removed? So we know that the whole thing is 11,250 and the cone is 3,375. So I suppose let's find what fraction of the whole thing is the cone. So it's going to be 11,250 pi all over 3,375 pi. And I can get rid of the 2 pi's. And I have now 3,375 divided by 11,250. And that actually gives me 0.3 on my calculator, which is the same as 3/10. So the question says then, if I take out the cone, what am I left with? So we've decided that the whole thing is 10/10. We said the cone is 3/10. So what would you be left with? You'd actually be left with 7/10 as your fraction. Okay, and just in a few people's work, I could see the 7/10, but I just didn't see the 3/10. So just make sure that you're showing which is which. Okay, the next part is really, I suppose, where I spotted most of the problems, and it is calculate 3 significant figures, the surface area of the remaining solid. So what has happened here? What fraction of the cylinder remains after the cone is removed? So we now have a shape, I suppose. We have the top of a cylinder, but we have this section here cut out, okay? And we want to find the surface area of that. So I suppose this is not a regular shape and very difficult to find the surface area of that. But let's have a look actually at what this shape is. So if I was to look at this shape, it is the area of a circle, so it's the full area of a circle, and then it's plus the whole curved surface area of the cylinder, because we go the whole way around. But inside it, we're taking away the curved surface area of the cone. Or sorry, we're adding in the curved surface area of the cone. So really, how do I find the surface area that remains? So it's the top of the cylinder plus the curved surface area of the cylinder plus the curved surface area of a cone. Okay, so top of the cylinder, well, we know that that's just going to be pi r squared. Curved surface area of a cylinder, well, we have a formula for that. 2 pi r h from page 10 of our log tables. And curved surface area of a cone, we have a formula for that. So if we work out all of these, add these together, we should get our total answer of this shape here. So the top of the cylinder, as I said before, is pi r squared. We know everything here. We know we're taking pi to be 3.14. And our r in this case, our diameter is 30, our r is 15. So 15 to be squared. Plus curved surface area of the cylinder, which we know now is 2 pi r h. So I should have all the information there. 2 times 3.14 times 15 times my height, which is 50 centimeters, plus the curved surface area of a cone. Now you will notice that with your cone here, the formula is pi r L, and that means within the cone here, our radius is always from here to here. From here to here is our height, but this section here that I'm doing in green, that's our L. So we actually need our L in this formula here. We need pi r and L. So I know that from the cone itself that this here is 15. I know that the height of the cone here is 45. And I'm going to use Pythagoras' theorem now to find out what L is. Okay, so you can see I've applied Pythagoras' theorem here, worked it down, and I've got 47.434 as what my L is. So I can now find, so it's going to be, I can do the last part here, the curved surface area, which is pi r L. And it would be 3.14 multiplied by my r, which is 15, multiplied by L, which I now know is 47.434. Okay, and that, guys, is all the hard work there. If I use my my knowledge, I should be able to figure all this out. So for this bit here, I should get 706.5 plus 4710 plus 2234.15, and that should give me 7650.65. And the question said, we zoom back in on it, it said to 3 significant figures. So remember, that means to 3 numbers basically, and zeros don't count if they're after it. So 7650 is my 3 significant figures. And remember, we're dealing with area, so it's going to be centimeters squared. So not too many people got that one right, but hopefully you've noticed, you've seen how I've done it and gone through the question. Our next lesson is going to be on the trapezoidal rule. So it's the last part of this before we move into exam questions.